Good day, seniors. In this video lesson, we'll be answering more problems about combinations. I've prepared few problems here. Let's begin. Problem 1. How many diagonals can be drawn in a convex polygon with 20 sides? Now you know that given the vertices of the polygon, there are also 20 vertices, and you can make 20C2. So these are the number of lines that can pass through any 2 points through the vertices of the polygon. But we'll be counting here the sides. So if we're only asked the diagonal, you should subtract the number of sides that this diagonal has. So you have your 20C2 minus 20. And then the answer is, if you have your calculators, bring that out and solve it with me. So you get here 170 diagonals. Now we can pretty much make a formula out of this. So we have n sides. So the number of diagonals is simply nc2 minus n. So let's have the next. In how many ways may a group of 10 judges reach a majority decision? So we have here 10 judges and they'll be voting on something. So to reach a majority decision, more than half of the judges should be agreeing on the same thing. So therefore, 6 judges is majority decision, 7, 8, 9, and 10. So pretty much the answer is simply 6 out of the 10 judges of 10C6. This will be a majority decision. Also 10C7, and 10C8, and 10C9. And of course, if all the judges vote or agree on something, it's 10C10. It's only, it's only one way of that happening. So to answer this problem, we add all these 5 cases up. So just add them up. 10C6 plus 10C7, 10C8, 10C9, and 10C10. So get the answer here is 386. Okay, let's have the next question. In a group of 6 boys and 4 girls, 4 are selected. In how many ways can they be selected such that at least one boy should be there? Now, remember that we are to select 4 out of the 10. 6 boys and 4 girls are 10 in all. So we are to select 4 only. So if at least one boy should be there. So case 1 is when we have exactly one boy picked. So it's 6C1 times, of course, if one of the 4 selected is a boy, then the other 3 must be a girl. So it's your 4C3. This is your boy, and this is your 3 girls. So another case that will satisfy this is that at least one boy should be there is, of course, when you have 2 boys selected, so 6C2. So that leaves only 2 girls to be selected, so 4C2. Then you have 3 boys, so 6C3 times, of course, you only have 1 boy to select, 4C1. And another way, the last case that will satisfy is that all 4 picked are boys. So 6C4, these are all boys. Number 1 boy, 3 girls, 2 boys, 2 girls, 3 boys, 1 girl, and all of them boys. So just again add all these cases up. 6C1 times 4C3 plus 6C2 times 4C2 plus 6C3 times 4C1 plus 6C4. So the answer here is 209. Now let's have another way of answering this problem. So if we are to select a committee that there should be at least one boy in there, why not get the number of ways that we select the 4 members that none of them is a boy? So this, the only case that's happening is that all girls are selected. So it's 4C4. So this is the number of ways that there's no boy selected. And we can subtract this from the total number of ways that we can select the 4 out of the 10. So it's 10C4 minus 4C4. It's another way of looking at it. Now again, help me out with your calculator. So 10C4 minus 4C4. Of course, we get the same answer as 209. So then, now let's have this problem. From a class of 10 students, in how many ways can a president, a vice president, and a VVP, vice president, be selected? if a bad boy is one of the selected officers. So we have here a problem that is not actually a combination problem. This is a permutation problem, since the order with which we are making the officers are important. So we have a president, a vice president, and a BVP. Another condition in the problem is that a bad boy is one of the selected officers. So remember, it's easy to see that there are only three cases wherein you have the president, the VP, and the BVP. And to make a bad boy one of them, so the case number one where it should be, let's just use simple counting here. So the president, let's have a bad boy as a president. So it's, this spot here is taken by a bad boy. Okay. And then you have here 9 only to choose for our VP, and then 8 to choose for our BVP. So we have here 72 ways. Now another case is that when a bad boy is your VP. So this is taken by a bad boy. So 9 ways to choose for president, and then 8 here. So you get here 72. And then the last case, and which will satisfy the conditions that a bad boy is your BVP. So 9 to choose for the president, 8 for the VP, and you have 72. Adding these three cases up, you get number of ways that the officer is selected, given that a bad boy is one of the officers, is 216. Right, so okay, let's have this, the last question here. From a class of 10 students, in how many ways can a group of 3 members be selected if a bad boy is one of the selected members? Now, that's why I included the previous question. This is a permutation problem. Basically the same question as the last one. But this time, we have here 3 members, so it's a committee, it's a group, therefore it's a combination problem. But the same condition as the previous problem, that the bad boy is one of the members. Now, there are 2 ways that can answer here. Let's do that, both. One way of looking at this question is that if we are to make a 3-member committee, and then one of them is already determined, and that's a bad boy, why not choose only 2 out of the remaining 9? You have 10 here, and you're excluding a bad boy from being picked because it's already picked. So you have 9 students to be chosen from, and you only have to choose 2. So that will answer the question, 9C2. You have 9C2, get here 36, so there are 36 ways. Now another way of looking at this problem, if we are to make a 3-member group and a bad boy is one of selected members, let's have the number of cases that a bad boy is not selected. So here, not selected. So if we are to choose a 3-member group wherein a bad boy is not selected, so we have to exclude a bad boy from being picked out of the 10. So we have here, it's simply 9C3. And then to answer the problem that a bad boy is one of them, this is a bad number of ways a bad boy is not one of them, we are to subtract this from the totality, which is 10C3, choosing 3 out of the 10. And that includes a bad boy from the choice. So you have here 10C3 minus 9C3. And you see the answer is the same. It's also 36. So again, I hope this clears the confusion between how to do this problem here, and then this kind of solution here. And also, like this one, in this problem can actually do this, subtract this from the totality, and then just enumerate the cases. Hope you enjoyed the lesson. Good day.